In question 1, we need to show all stages of the working, and solutions relying on calculator technology are not acceptable. Well, we need to use algebra to solve the given quadratic inequality, and I will start by collecting everything on the left hand side. So we've got x squared minus x minus 20 being greater than 0. Now this factorizes into x minus 5 times x plus 4, and I will proceed by finding the critical values, which are those values of x that make the left hand side 0. So we're looking at x minus 5 being equal to 0 and x plus 4 being equal to 0. So we've got the two critical values being x is 5 and x is negative 4. And I will proceed by sketching a smiley face parabola. Now this is a smiley face parabola because the term in x squared is positive, so the coefficient of the leading term is 1, which is positive. So we're looking at a U-shaped parabola with the critical values being negative 4 and 5, which goes plus, minus, plus. And when we say plus, we mean that the y values are positive, so the parabola lies above the x-axis, while between negative 4 and 5 we lie below the x-axis, and therefore the y values are negative. Now we want to be greater than 0, so I'm going to be highlighting the tails, and we need to give our answer. It says in set notation, so the solution set is all values of x such that x is a real number and x is less than negative 4, or so union x such that x belongs to the reals and x is greater than 5. Notice that since the original inequality was a strict one, so is my solution here. So we've got strict inequalities in the final answer. In question 2, we need to show all stages of the working. We cannot rely on calculator technology to get our solutions. So we've got that 9 to the x minus 1 over 3 to the y plus 2 is 81. And we need to express y in terms of x, writing our answer in its simplest form. So the first thing to notice is that we're dealing with powers of 3 here. So starting with the original equation, I first notice that 9 is 3 raised to the power of 2 and then raised to the power of x minus 1 over 3 to the y plus 2 is equal to 3 to the power of 4. Now we know that when we raise a power to a power, we multiply the powers together. So we're looking at 3 to the 2x minus 2 over 3 to the y plus 2 is equal to 3 to the power of 4. And then when I divide with a common base, I subtract the indices. So we're looking at 3 to the 2x minus 2 minus brackets y plus 2 is equal to 3 to the power of 4. I can simplify the exponents now. So it's 3 to the 2x minus 2 minus y minus 2 is equal to 3 to the power of 4. And therefore we've got 3 to the 2x minus y minus 4 is equal to 3 to the power of 4. Now since each side of the equation is a single power of 3, then I can equate the exponents, the powers, and we've got 2x minus y minus 4 is equal to 4. Remember, we're trying to make y the subject here, so we've got 2x minus 8 being equal to y. In question 3, we need to integrate the given expression with respect to x, writing our answer in its simplest form. Well, the first thing to do is split this. So we're looking at the integral of 3x to the power of 4 over 2x to the power of 3 minus 4 over 2x to the power of 3 dx. I will simplify this. It's the integral of 3 over 2x minus 2x to the negative 3 dx. And I will now proceed into integrating. We know that in integration we increase the power by 1 and we divide by the new power. So it's going to be 3 over 2 times x squared over 2 minus 2x to the negative 2 over negative 2 plus the constant of integration. Now we've got simplifications. The 2 here with the 2 will cancel out. The minus with the minus will give me a plus. So all in all, we're looking at 3 over 4x squared plus x to the negative 2 plus c. Question 4 is on vectors. We've got a stone sliding horizontally across ice. It's initially at the point A with position vector negative 24i, negative 10j relative to a fixed point O. 4 seconds later, it's at the point B with position vector 12i plus 5j. We are modeling the motion of the stone as that of a particle moving in a straight line at constant speed, and we need to prove that the stone passes through O. Now, one approach I could use here is simply draw a straight line joining points A and B, so it's something like this, and all I have to do is show that the point O, the origin, lies on this straight line. So I could approach this purely through a straight line approach. So we're looking at the gradient of AB to start off with. So this is 5 minus the negative 10 over 12 minus the negative 24. So this is giving an answer of 5 over 12. So at the back of my mind, I'm trying to find the equation of the straight line passing through the points A and B, and then show that the origin is a point on this line. So to do that, I'm going to use the fact that y minus y1 is m times x minus x1, and I'll be using the point B with coordinates 12, 5. So we've got y minus 5 is equal to 5 over 12 times x minus 12. I will expand this to get y minus 5 is equal to 5 over 12x minus 5, and therefore we conclude that y is 5 over 12x is the equation of the straight line passing through A and B. I will then proceed by saying that when x is 0, I'll substitute this into the equation of the straight line we just found. So y is 5 over 12 times 0, which gives an answer of 0. And therefore, we conclude that the stone passes through the point O. Alternatively, we could have said that OA is negative 24, negative 10. OB is equal to 12, 5. We notice that 12, 5 is parallel to negative 24, negative 10, because the ratio of the I to j components is the same for both vectors, and therefore we conclude that OA is parallel to OB, and therefore A, O, and B lie on the same straight line, which helps us conclude that the stone will pass through point O. In part B, we need to calculate the speed of the stone, and I will start by calculating the distance AB. So this is going to be 12 minus the negative 24 squared. So I'm doing y2 minus y1 squared plus x2 minus x1 squared. So 5 minus the negative 10 squared and all square root. This will give me the distance AB, which turns out to be 39. Now we know that speed is given by distance over time because we were told that the speed is assumed to be constant throughout motion. So the distance is 39 meters. This was covered in 4 seconds, and therefore we conclude that the speed is 9.75 meters per second. In question 5, we're given part of the curve with equation y is 3x squared minus 2. The point P with coordinates 2, 10 lies on the curve, and we need to determine the gradient of the tangent to the curve at P. So this is calling for differentiation. Now dy dx we multiply by the power and we deduct 1 from the power. It's giving me 6x, and therefore I will evaluate dy dx when x is 2. This will give me the gradient of the tangent. So 6 times 2 gives an answer of 12. Now the point Q with x coordinate 2 plus h also lies on the curve, and we need to find the gradient of the line PQ, giving our answer in terms of h in its simplest form. So I will first start by finding the y coordinate at the particular point where x is 2 plus h. So I'm going to say that when x is equal to 2 plus h, we've got y is 3 times 2 plus h squared minus 2. I will proceed in expanding. It's 3 times 4 plus 4h plus h squared minus 2. And this gives me 12 plus 12h plus 3h squared minus 2, which simplifies to 3h squared plus 12h plus 10. And therefore we conclude that the point Q has coordinates 2 plus h, 3h squared plus 12h plus 10. Now the gradient of PQ is given by y2 minus y1 over x2 minus x1. So we've got 3h squared plus 12h plus 10 minus 10 over the 2 plus h minus the 2. So we notice that the 10 with the negative 10 will cancel out, the 2 with the negative 2 will cancel out, and this simplifies to 3h plus 12, which is the gradient of the chord PQ. In C, we need to explain briefly the relationship between part B and the answer to part A. So if I go back to the diagram here, we've got an expression for the gradient of the chord PQ, and we've got the gradient of the tangent at the point P. So we can see that if Q gets infinitely close to P, then the two coincide. And actually, if we look at our answers, we can see that as h goes to 0, this vanishes and we are left with 12, which is exactly the answer we got in part A. So I'm going to simply say that as h tends to 0, the gradient of PQ goes to 12, and therefore we can see that this is equal to the gradient of the tangent. In question 6a, we need to use algebra to find all solutions of this equation here. So it's a cubic equation. We expect up to a total of 3 solutions. And I will start by factoring out the x. So we're looking at x brackets 3x squared minus 17x minus 6 being equal to 0. And I will proceed in further factorizing the quadratic here, taking me to x brackets 3x plus 1 times x minus 6 being equal to 0, which means that either x is 0, or we've got that 3x plus 1 is 0, or that x minus 6 is equal to 0. So we've got 3x is negative 1, so x is minus 1 over 3, or x is 6, or x is 0. So we've got a total of 3 distinct solutions. In part B, we're asked to hence find all real solutions of this equation here. It's a part B of the equation. There is clearly a connection with part A, and we notice that x becomes y minus 2 all squared, and similarly x squared with y minus 2 raised to the power of 4, and x cubed becoming y minus 2 to the power of 6. So I will start by stating that we consider that x is equal to y minus 2 squared, which is surely greater than or equal to 0, because any squared quantity cannot be negative, and therefore using the solutions we obtain from part A, we can say that y minus 2 squared is equal to 0, or we've got that y minus 2 squared is equal to minus a third, or alternatively y minus 2 squared is equal to 6. Now from the first equation here, we've got y minus 2 being equal to 0, and therefore y is equal to 2. Now y minus 2 squared cannot be negative a third, because we said that anything squared cannot be negative. So I'm going to say here that I reject this. It's not valid. And then for the third option, y minus 2 all squared being 6, we can say that y minus 2 is plus minus root 6, which leads to y is 2 plus minus root 6. So a total of 3 solutions, the 2 plus root 6, the 2 minus root 6, and the y being equal to 2. In question 7, we're given that the parallelogram PQRS has an area of 50 square centimeters. Now PQ has a length of 14 centimeters, QR has a length of 7 centimeters, and angle SPQ is obtuse, and we need to determine the size of this angle in degrees to 2 decimal places. Well, it makes sense to start by drawing PQRS. We've got all the measurements here, and we're trying to determine the size of the angle SPQ. It's the angle P here. We know that the area of this parallelogram is 50 square centimeters, so we know that the area of this parallelogram is given by the area of the triangle SPQ multiplied by 2. So I'm going to say that the area of the parallelogram PQRS is given by 2 times the area of this triangle, which is a half AB sine C. So a half times 14 times 7 times the sine of the angle P. Now the 2 will cancel out. We've got that the area is 50, and we arrive at 50 is equal to 98 sine of P, and therefore 50 over 98 is the sine of P. I will proceed by doing shift sine of 50 over 98, so P is shift sine of 50 over 98. If we plug this on the calculator, we get an answer of 30.677 ... However, bearing in mind that angle SPQ is obtuse, we need to do 180 minus the answer we just got. So SPQ is going to be 180 minus 30.677 ... which is 149.3225 ... which correct to 2 decimal places is 149.32 degrees. In part B, we need to determine the length of the diagonal SQ in centimeters to 1 decimal place. So I will start by drawing the diagonal here, and the plan is to use the cosine rule because we now know that the angle P here is 149.3225 ... which means that SQ squared is equal to 14 squared plus 7 squared minus 2 times 14 times 7 times the cosine of 149.32 ... If I plug the right hand side on the calculator, we get that SQ squared is 413.570 ... I will take the square root of this to get that SQ is 20.336 ... and therefore correct to 1 decimal place, it's 20.3 centimeters. Question 8 is on the binomial expansion. We've got g of x to be 2 plus ax raised to the power of 8. A is a constant. Additionally, we are told that one of the terms in this expansion is 3,402x to the power of 5, and we need to find the value of a. So we've got 2 plus ax raised to the power of 8. I'm not going to go through the full expansion. I'm just going to go straight away to the term in x to the power of 5. So we've got ... plus 8, choose 5. And we've got 2 raised to the power of 3, and then ax raised to the power of 5. Now remember that the sum of the two powers is always giving me the original power. So plus ... and I will proceed in simplifying this. So we've got 448a to the power of 5, x to the power of 5 plus ... and therefore 448a to the power of 5 is equal to 3,402, which means that a to the power of 5 is 3,402 over 448, which simplifies to 243 over 32, and therefore a is going to be the fifth root of 243 over 32, which gives an answer of 3 over 2. Now, using this value of a, we need to find the constant term in the expansion of this expression here. So we're looking at 1 plus 1 over x to the power of 4 times 2 plus 3 over 2x raised to the power of 8. So we are looking for the constant term, and we need to realize here that I need to do the constant times the constant term from this bracket plus the 1 over x to the 4 times the term in x to the 4 from this expansion here. These are the two combinations that can give me a constant term. So we're looking at 1 plus 1 over x to the power of 4, and then in the expansion of 2 plus 0 over 2x to the power of 8, we are looking at the first term being 2 to the 8, which is something I will need when I do 1 times 2 to the 8, because this is giving me a constant term, plus ... plus 8, choose 4, 2 to the power of 4, 3x over 2 raised to the power of 4, plus ... This will give me the x to the 4th term, which multiplied with 1 over x to the 4 will give me another constant term. So all in all, we are looking at 1 plus 1 over x to the power of 4 times 256 plus ... plus 5,670 x to the power of 4 plus dot dot dot. Now we can see that we're only interested in 1 times 256 and 1 over x to the 4 times the 5670 x to the power of 4, which leads to 256 plus 5,670 plus dot dot dot, which is 5926 plus dot dot dot, and therefore we conclude that the constant term is 5,926. In question 9, we are asked to find the value of the constant k lying between 0 and 9 such that this integral gives a result of 20. So we're looking at the integral from k up to 9 of 6x to the minus a half dx. Well, we know that in integration we increase the power by 1 and we divide by the new power. So it's going to be 6 times x to the a half over a half, and then the limits are k and 9. So we're looking at 12 root x from k up to 9. I will substitute the upper limit, so it's 12 root 9 minus 12 root k, and this is equal to 20. Now 12 root 9 is 12 times 3, which is 36. So we've got 36 minus 12 root k is equal to 20, which takes me to 16 being equal to 12 root k. Now 16 over 12 simplifies to 4 over 3, which is the root k, and therefore if I square everything, you get that 4 over 3 squared is the value of k, and we arrive at 16 over 9 to be the value of k. Now actually I can go on my calculator and confirm, validate my answer, so I can say that the integral of 6 over the root of x from the value of k that we found, which is 16 over 9. So I'm going to put 16 over 9 for the lower limit, and the upper limit, it's going to be the 9. I press the equal sign, I get an answer of 20, and therefore I confirm that I've got the right answer for k. Question 10 is on proof. We've got a student who's investigating the following statement about natural numbers. Well, natural numbers are the positive integers. Well, the statement says that n cubed minus n is a multiple of 4, and we need to prove this using algebra being true for all odd numbers. So I will start by saying consider n to be 2k plus 1, where k is an integer. This ensures that we are starting with an odd number. And then we've got n cubed minus n, which is 2k plus 1 raised to the power of 3 minus the 2k plus 1. Now, instead of expanding the bracket raised to the power of 3, I notice that 2k plus 1 is a common factor. So we're looking at 2k plus 1 times the 2k plus 1 raised to the power of 2 minus 1. I will proceed into 2k plus 1 times 4k squared plus 4k plus 1 minus 1. Now the 1 with the minus 1 will cancel out, and we can see that we can factor out a 4. So we're looking at 4 times 2k plus 1 times k squared plus k, which is obviously a multiple of 4, and therefore we conclude that n cubed minus n is a multiple of 4 for all odd numbers. In part B, we need to use a counter example to show that the statement is not always true. Now with a counter example, we mean a particular specific value for n that will show that n cubed minus n is not a multiple of 4. Now from part A, we know that if n is an odd number, then this is certainly true. So I need to look into the even numbers. So I'm going to say consider an even number. I will consider n being 2. This means that n cubed minus n is 2 to the power of 3 minus 2, which is 8 minus 2, which is equal to 6, which is obviously not a multiple of 4. Question 11 is a modeling question. We are told that the owners of a nature reserve decided to increase the area covered by trees. Now, tree planting started on the 1st of January of 2005. The area covered by trees is given by a square kilometers and is modeled through this exponential equation. C is a constant and T is the number of years after the 1st of January of 2005? Well, we need to use the model to find the area of the reserve covered by trees just before the tree planting started, so the initial area covered by trees, which simply means we need to put t is 0. So when t is equal to 0, we get that a is 80 minus 45 e to the power of 0. Well, we know that e to the power of 0 is 1, so 80 minus 45 is 35, and this is square kilometers. We need to include the units to get the mark because this is a modeling question, so all answers should be in context. Now, on the 1st January of 2019, an area of 60 square kilometers of the reserve was covered by trees, and we need to use this information to find a complete equation for the model, giving the value of C to 3 significant figures. So, we know that on the 1st of January of 2005, t had a value of 0, it was the initial time. So on the 1st January of 2006, t is 1, and if I continue like this, on the 1st January of 2019, t will be equal to 14, so I will be substituting 14 for t, so we've got 60 is 80 minus 45 e to the 14c, which leads to 45 e to the 14c being equal to 20. Now if I divide both sides by 45, we get that e to the power of 14c is equal to 4 over 9, and I will remove the exponential term by taking ln of both sides, taking me to 14c being equal to ln of 4 over 9, and therefore c is 1 over 14 ln of 4 over 9. Now if we plug this on the calculator, we get that c is negative 0.057923 ... Well, we are told to find the complete equation of the model, so my final answer is that capital A, the area, is equal to 80 minus 45 e to the minus 0.0579 t. Now, on the 1st January of 2020, the owners of the reserve announced a long-term plan to have 100 square kilometers of the reserve covered by trees, and we need to state the reason why the model is not appropriate for this plan. Well, using the full equation of the model we have arrived at in part B, we can see that as t tends to infinity, the exponential term tends to 0, and therefore a goes to 80. This means that the maximum area covered by trees according to this model is only 80 square kilometers, and therefore the model is not appropriate. Alternatively, you could have tried setting this to be equal to 100. It will lead to minus 20 being 45 e to the minus 0.05 t. We know that the exponential term can never give you a negative result, and therefore this yields no solutions, which is another way of approaching this question. In question 12, we need to show all stages of the working, and solutions relying entirely on calculator technology are not acceptable, so we need to be careful here. We're dealing with a trigonometric equation. We need to find all solutions. Theta lies between 0 and 450, and we need to give our answers to one decimal place. Now the first thing to do is write cos squared as 1 minus sine squared. So we're looking at 5 times 1 minus sine squared theta being equal to 6 sine theta. I will expand to get 5 minus 5 sine squared theta is equal to 6 sine theta. And I'll be collecting everything on the right hand side to get 0 is equal to 5 sine squared theta plus 6 sine theta minus 5. I will proceed with the quadratic formula. So we're looking at sine theta is minus 6 plus minus the square root of 6 squared minus 4 times 5 times negative 5, and everything divided by 2 times 5. Now it's okay to go on my calculator to run the quadratic formula, so I press menu, it's option A, it's polynomial of degree 2. Now we've got A is 5, we've got B is 6, and we've got C is negative 5. So the first solution is minus 3 plus root 34 over 5. So I'll write this here. Sine theta is minus 3 plus root of 34 over 5. Let me evaluate this numerically. It's 0.566 dot dot dot, and I will store this on A. So my A key now holds the exact value for sine theta of 0.566 dot dot dot. Alternatively, let me press the equal sign. The second solution is that sine of theta is equal to minus 3 minus root 34 over 5. Let me press the SD button. It's minus 1.76 dot dot dot. It's beyond the negative 1 to 1 corridor, so we know that on this side we've got no solution, so we reject this. It's not valid because the sine of any angle varies between minus 1 and 1, and therefore we can proceed with this equation here to find all solutions. The first thing to do is find the principal value, so the PV will be shift sine of the 0.566 dot dot dot. So menu 1, I'll do shift sine of A, and this gives an answer of 34.484 dot dot dot, and I will store this on B. And we know that when we are solving a trigonometric equation involving sine, then theta is given by the PV, which is B. Let me write the B here to remember. So it's going to be B plus the 360K, or alternatively theta is 180 minus the PV of B plus 360K. So I'm going to press menu, option 9, my f of x is B plus 360x, and my g of x is going to be 180 minus the b plus the 360x. So I'm planning on automating the whole process on the calculator. I will start at -2, I will end at 5. I'm stepping every one, so essentially the calculator will be replacing x with -2, then -1, 0, 1 up to 5. So all of these are the solutions. So we are between 0 and 450. So we can see that the first solution is 34.5. So let me write this down. Theta is 34.5. Then we go to 145.5. So we're giving answers to one decimal place. And then the third answer is 394.5. So we've got a total of 3 solutions. In II, we've got the student's attempt to solve the equation 3 tan x minus 5 sine x is 0 for x between minus 90 and 90. So the student started by writing tan x as sine x over cos x. They have multiplied throughout by cos x to get rid of the denominators, and then they divided throughout by sine x, arriving at cos x is 3 over 5, giving a solution of 53.1. Now we are told to identify 2 errors or omissions made by these students, giving a brief explanation of each of these. So the first thing is when they divided by sine x. Now dividing by sine x means we have completely omitted the fact that sine x is 0 is indeed a solution. They should have actually factored out the sine x, leading to sine x 3 minus 5 cos x being equal to 0, and this would have led to sine x being 0, giving me some extra solutions. So the first thing we say is that the student should have also considered solutions to sine x is 0. And the second error is that at the very end, when they found x is 53.1, there are other solutions to this trigonometric equation to cos x is 3 over 5. We know that x is 53.1 or x is minus 53.1 would also be a solution. So we've got 2 errors committed by the student here. We now have that the first 4 positive solutions in order of size of this equation here are alpha 1, 2, 3, and 4. And we need to find to the nearest degree the value of alpha 4. I will start by solving this trigonometric equation as it stands. So the first thing to do is find the principal value. So my PV is going to be shift cos of 3 over 5. So I'm going to go on my calculator. I'll do shift cos, and I've got 3 over 5. I press the equal sign. I get 53.13 dot dot dot, and I will store it on A. So let me write an A here. So we know that 5 alpha plus 40 is equal to the plus minus PV plus 360K. I will split this now, one for the plus and one for the negative. So 5 alpha plus 40 is equal to A plus 360K, or 5 alpha plus 40 is equal to negative A plus 360K. I'm solving for alpha, so 5 alpha is A minus 40 plus 360K, leading to alpha is A minus 40 plus 360K, and all of it divided by 5, and also 5 alpha is negative A minus 40 plus 360K, so alpha is minus A minus 40 plus 360K over 5. Once more, I'm going to go on my calculator. I press menu, it's option 9, and we go to f of x, which is going to be the A minus the 40 plus the 360x, and everything divided by 5. This is the first equation. The second equation goes negative A, and we've got minus 40 plus the 360x, and everything divided by 5. I will go from negative 2 up to 5. We're looking for the fourth positive solution. So let's see all the solutions. The first solution is here at 2.63. Let me write everything down. Alpha is 2.63. I'm only listing the positive solutions in ascending order. So the second solution is the 53.37. Then we've got the 74.63. And then the fourth solution, it's the 125.37. Remember, the question is asking for the fourth solution for alpha 4 here to the nearest degree, and therefore we conclude that alpha is 125 degrees. In question 13, we've got the resting heart rate H of a mammal measured in beats per minute modeled through this equation here, where P and Q are constants and M is the mass of the mammal measured in kilograms. Now we've got a linear relationship illustrated here between log of H base 10 and log of M base 10. We can see that we are cutting the vertical axis at 2.25, and the gradient of this straight line is negative 0.235. And we need to determine to three significant figures, the value of P and the value of Q. So I will start by writing the equation of the straight line between log H and log M. So we're looking at log of H base 10 being equal to the negative 0.235 log M base 10 plus 2.25. Now the equation of the proposed model is H is Pm to the Q. So starting with this, I will take log of both sides. So log of H base 10 is log of Pm to the Q base 10. I will proceed on the right hand side to split this as log of P base 10 plus log of M to the Q base 10, because we know that the log of the product is the sum of the logarithms, and then using the power law of logarithms, we know that log of H base 10 is equal to log of P base 10 plus Q log of M base 10. I can now proceed with comparing the two equations. The coefficient of log M is the Q, and the constant term, the 2.25, is the log of P base 10. This simply means that log of P base 10 is equal to 2.25, and then Q is negative 0.235. Now to find P, I will simply do P is 10 to the 2.25. This gives an answer of 177.8279 ... which correct to three significant figures is 178. Now a particular mammal has a mass of 5 kilograms and a resting heart rate of 119 beats per minute, and we need to comment on the suitability of the model for this mammal. So this is the full equation of the model. So we will be substituting m is 5. So when the mass m is 5, then h is 178 times 5 to the minus 0.235. When evaluated on the calculator, gives an answer of 121.94 ... which is the resting heart rate predicted by the model. The actual resting heart rate is 119. Now 119 and 122 are quite close, and therefore we conclude that the model is suitable for this mammal. In part C, we need to interpret the value of the constant P with reference to the model. So the model was H is Pm to the Q. We notice that when we put m to be 1, we arrive at H being equal to P times 1 to the power of Q, which is simply P. Well, we have found P to be 178. And therefore we conclude that if we've got a mammal with a mass of 1 kilogram, then we are predicting 178 beats per minute. In 14, we've got f of x to be this quadratic here, and we need to express it in this form where a, b, and c are constants to be found. So this is calling for completing the square. So we start with f of x being equal to minus 3x squared plus 12x plus 8. The first thing to do is factor out the negative 3, so it's negative 3, and I've got x squared minus 4x, and with close brackets plus 8, and I will be completing the square on x squared minus 4x. So we're looking at negative 3, and I've got x minus 2 all squared minus 2 squared plus 8, which takes me to negative 3 times the x minus 2 squared minus 4 close brackets plus 8, which further leads to negative 3 times x minus 2 squared plus 12 plus 8, and therefore we arrive at negative 3 times x minus 2 squared plus 20. So we conclude that f of x can be written in exactly the form proposed by the question as negative 3 x minus 2 squared plus 20. Now, in case you are not comfortable with completing the square, an alternative is to use equating coefficients. So we're looking at minus 3x squared plus 12x plus 8 being equal to a brackets x plus b squared plus c. I will expand this to get ax squared plus 2bx plus b squared plus c, which gives me ax squared plus 2abx plus ab squared plus c. I can then proceed by comparing coefficients. I've got minus 3x squared on the left hand side and ax squared on the right hand side. I've got 12x on the left hand side and 2abx on the right hand side, and I've got 8, the constant term, on the left, and ab squared plus c on the right. We can therefore see that the negative 3 is equal to a, so let me write this down. We've got negative 3 is equal to a. Then we've got the 12 here being equal to 2ab. So if 12 is equal to 2ab, and we know that a is negative 3, so it's going to be 2 times negative 3 times b, taking me to 12 is negative 6b, and therefore b is negative 2. And finally, the 8 is equal to ab squared plus c. So if 8 is ab squared plus c, we know that a is negative 3, b is negative 2, so negative 2 squared plus c, which means that 8 is negative 12 plus c, which means that 20 is equal to c. And I need to write my final answer. So f of x is going to be the a, which was found to be negative 3, x plus the b, so x minus 2 squared plus 20, which of course agrees with the answer we obtained using completing the square. Now the curve C has a maximum turning point at point M, and we need to find the coordinates of M. Now that we have written f of x in this particular form, we know that the turning point is attained when the bracket here is 0, and the bracket will be 0 when x is 2, so the x coordinate of M will be 2, and when this is 2, this whole bracket is 0, and y is equal to 20, so the coordinates of M are 2, 20. Now in figure 3, we've got a sketch of the curve C. We are told that the line L passes through the maximum point and is parallel to the x-axis, so we're looking at a horizontal line, and we need to use algebraic integration to determine the shaded area R. So we know the equation of the curve. We also know the coordinates of point M, it's 2, 20. So the idea is the following. I could start with the area of this rectangle which I have shaded, and then I will integrate this curve from 0 up to 2. This will give me the area below the curve and above the x-axis. So the area of the rectangle minus the area here will give me exactly the area of the region R. So let's go. We've got that capital R is the area of the rectangle, which is 2 times 20 minus the integral from 0 up to 2 of minus 3x squared plus 12x plus 8 with respect to x. So we're looking at 40 minus, and I've got minus 3x cubed over 3 plus 12x squared over 2 plus 8x, and the limits are 0 and 2. We notice that the 3 with the 3 will cancel out. The 12 with the 2 will leave me a 6 in the numerator. So we're looking at 40 minus the negative x cubed plus 6x squared plus 8x, and the limits are 0 and 2. So we've got 40 minus, I'll be substituting the upper limit, so minus 2 cubed plus 6 times 2 squared plus 8 times 2, and the overall contribution from the lower limit of 0 is 0 because all of these give me a result of 0. So I've got minus 0 here. So I can proceed into evaluating this bracket here, which gives an answer of 32. So we've got 40 minus 32, and we conclude that the area of the region R is 8 square units. In question 15, we're given a sketch of the circle C centered at the point N with coordinates 7, 4. We've got the line L with the equation y is a third x being a tangent to C at the point P. And we need to determine an equation for the line PN. It's the line here passing through the center of the circle and the point P. And we need to give our answer in the form y is mx plus c, where m and c are constants. So the first thing to do is annotate our diagram. We've got the line L with the equation y is a third x. If I join N with P, the radius there is making an angle of 90 degrees with the straight line L. Well, we know that the gradient of L is a third, and therefore this means that the gradient of the line PN, it's going to be minus 3. So I flip and I change the sign to find the gradient of the perpendicular. And since we've got a point and the gradient, we can use y minus y1 is mx minus x1 to find the equation of the straight line. So we're looking at y minus 4 is negative 3 times x minus 7, leading to y minus 4 is negative 3x plus 21, and therefore we arrive at y is negative 3x plus 25. In part B, we need to find an equation for C. So looking at the diagram we were given, let's add all the information we have up to this moment. We've got the equation of the line L. We've got the point N having coordinates 7, 4. We have found the equation of the line passing through P and N. And we know that point P is the point of intersection of these two lines. So at P, we've got the third x, which is equal to y, being equal to minus 3x plus 25. I will multiply throughout by 3 to get that x is minus 9x plus 75. which leads to 10x is 75, and therefore this gives me x to be 15 over 2. I will proceed in finding y, so y is a third x, so a third times 15 over 2, which gives an answer of 5 over 2, and therefore we conclude that the point P has coordinates 15 over 2, 5 over 2. So we've got the coordinates of the center, we've got the coordinates of a point on the circumference. I can find the radius of this circle by doing the distance between P and N. So the radius will be given by 7 minus 15 over 2 squared plus the 4 minus the 5 over 2 squared and all square root. This gives an answer of root 10 over 2, which is the radius of the circle. And using the fact that the circle centered at the point alpha beta with the radius r has equation x minus alpha squared plus y minus beta squared is r squared, we can say that x minus 7 squared plus y minus 4 squared is equal to root 10 over 2 squared, which simplifies to 5 over 2. Now the line with equation y is a third x plus k, where k is a non-zero constant, is also a tangent to c, and we need to find the value of k. So the diagram is like this. This is all the information we've got up to now. Now the line with equation y is a third x plus k is certainly parallel to the line L because they have the same gradient, and for it to be a tangent to c, it means that it must be something like this. We're trying to find the value of the constant k, and to do that I will first find the coordinates of the point at which this line is tangential to the circle. I'll call it q with coordinates x, y, and we know that the midpoint of q and p is the center of the circle. This means that x plus 15 over 2 is equal to 7, and y plus 5 over 2 is equal to 4, taking me to x plus 15 over 2 is equal to 14, and therefore x is 13 over 2, and y plus 5 over 2 is equal to 8, which means that y is 11 over 2. So I've got the coordinates of the point Q, and I know this point lies on this line, so I'll be substituting x with 13 over 2 and y with 11 over 2. So we've got 11 over 2 is equal to a third times 13 over 2 plus k, which leads to 11 over 2 is equal to 13 over 6 plus k, and therefore k turns out to be 10 over 3. In question 16, we are told that the curve C has equation y is f of x, where f of x is this cubic here, a and b are constants. Additionally, we are told that the point 2, 10 lies on C, and the gradient of the curve at this point is negative 3, and we need to show that the value of a is negative 2, and then proceed in finding the value of b. Well, I will start with the fact that the gradient at x is 2, so f dash of 2 is negative 3. I will find an expression for f dash of x, so it's going to be 3ax squared plus 30x minus 39. I will evaluate this at x is 2, which is giving me 3a times 2 squared plus 30 times 2 minus 39. So we're looking at 12a plus 21, and we know that this is equal to negative 3. So 12a is negative 24, and we arrive at a is negative 2 as required. Now to proceed and find the value of b, I will use the fact that f of 2 is equal to 10, and therefore we've got that 10 is equal to negative 2 times 2 to the power of 3 plus 15 times 2 to the power of 2 minus 39 times 2 plus b. So I have substituted a with the negative 2 we just found. We have substituted x with 2. The only unknown is b. So we've got 10 is equal to negative 34 plus b, and therefore we conclude that the value of b is 44. In part B, we need to hence show that C has no stationary points, and I will start by stating f dash of x now that we've got the values for A and B. So it's going to be 3 times the ax squared plus 30x minus 39, which simplifies to negative 6x squared plus 30x minus 39. Well, we know that the stationary point satisfies that f dash of x is 0. So the idea here is that if we've got no stationary points, it means that this quadratic has no real solutions, and this immediately hints at considering the discriminant. The idea is that if we show that the discriminant is negative, we will be able to conclude that we've got no solutions and therefore we've got no stationary points. So the discriminant is b squared, so 30 squared minus 4ac, so minus 4 times negative 6 times negative 39, which is equal to negative 36, which is less than 0. And therefore we conclude that we've got no solutions to f dash of x is 0, which simply means that C has no stationary points. In part C, we need to write f of x in the form x minus 4 times q of x, where q of x is a quadratic expression to be found. So at the moment, we've got that f of x is minus 2x cubed plus 15x squared minus 39x plus 44. And the obvious next step is to proceed with the long division. So I will divide by x minus 4. So I'm always trying to match the highest order term on the left-hand side. So I need to multiply x by negative 2x squared to get negative 2x cubed plus 8x squared. And then we deduct. We get 7x squared minus 39x plus 44. I need a plus 7x here. So 7x squared minus 28x, and I deduct once again. So we get negative 11x plus 44. So I've got a negative 11 here. This is negative 11x plus 44, leaving me with a remainder of 0 as expected. And therefore, we've got that f of x is equal to x minus 4 times negative 2x squared plus 7x minus 11. Now in part D, we are asked to hence deduce the coordinates of the points of intersection of the curve with equation y is f of 0.2x and the coordinate axis. Well, I will start by considering the original f of x. We know that if we are intersecting the y-axis, this means that x is 0. So if I do f of 0 and I substitute into the expression we had for f of x here, we can simply see that the answer is 44. So f of 0 is 44, and therefore we are cutting the y-axis at 0,44. And if we are intersecting the x-axis, this means that y is equal to 0, and therefore we've got x minus 4 times the negative 2x squared plus 7x minus 11 being equal to 0. So either x minus 4 is 0, or alternatively, negative 2x squared plus 7x minus 11 is equal to 0. Now, obviously, x is 4 is a solution. However, for the quadratic here, I will consider the discriminant. So the discriminant is b squared minus 4ac. So in our case, it's 7 squared minus 4 times the negative 2 times the negative 11, which gives an answer of negative 39, which is less than 0. And therefore, we conclude that the quadratic will yield no real solutions. And therefore, the only cut on the x-axis is at the point 4, 0. Now the question is asking for y is f of 0.2x. We know that this means that we're dividing x by 0.2, which is the same as multiplying x by 5. And therefore the cut on the y-axis remains unaffected because the x-coordinate of 0 when multiplied by 5 will remain at 5. So we've got 0,44, while the cut on the x-axis, which was at 4, 0, will now be at 20, 0 because we have multiplied 4 by 5. Therefore, these are the coordinates of the points where the equation is cutting through the coordinate axis.